Good day, I'm Dr. T and welcome to my office. So in a previous video I rambled on about different ways you can talk about how much solute is in your solution. But how much solute can you cram into your solution? Well, there's a couple of things that are going to factor in here for this one. For starters, it does matter what your solute is and what your solvent is. There are definitely scenarios where you can mix any old ratio. In one blend, your solute may actually become the solvent because you can change the ratios of these to literally anything you want. If these are both liquids, we usually call them miscible because they will simply mix and they become, hey, whatever ratio you want. They don't just mix, good old oil and water. We call those immiscible because, well, they don't mix. But if you do have oil and water, what you'll actually find rather interesting is that a tiny amount of water does dissolve in the oil, and a tiny amount of oil will dissolve in the water. Now, what's going to affect how much gets in each one? Obviously, the type of molecule makes a huge difference, but the actual physical environment is going to play an important role. Depending on what you're trying to mix, I'm going to start with a simple one, and that's going to be a solid dissolved in a liquid. This could be something like water, a nice aqueous solution, or it could be something that's not water. Typically speaking, when solids dissolve in liquids, the higher the temperature you have, the more you can dissolve. Now, this is not always the case, and for some things, a raise in temperature really increases the amount you can dissolve. For other things, it increases it, but not by much. Once you reach as much solute that you can cram into your solution, we call that concentrated. Now, for gases going into liquids, things get a little bit different in this case. For those, there's two key factors. For starters, temperature is a major factor, but this one's actually inverted. So for most gases, the higher the temperature, the less you can dissolve into it. So a nice cold liquid is going to dissolve more gas. Now, I should point out, once you start freezing, things don't go well. But almost freezing is usually your best bet. That's why you see really big fish in the Arctic. They can breathe better. There's more dissolved oxygen in really cold water than there is in warm water. Notice how the tropics, how you have lots of colorful little fish. Yeah, that's not an accident. Admittedly, there's some big fish. I mean, the sunfish are huge. But, you don't have schools of tuna, which if you've ever seen a tuna are big. The other feature that affects how much gas will dissolve in a liquid is how much gas there is to dissolve. In this case, it's going to be the partial pressure. So partial pressure is describing how much of a certain type of gas is bouncing around in the air above the liquid. If it's in a container, usually we call that little gap the headspace. And this is why, if you've got some soda, you are well advised to take that nice 2-liter bottle of soda from the store, put it in the fridge, and leave it there until it gets nice and cold. Before you open that bottle, that headspace is filled with CO2. And if you notice that bottle is really rigid, that's because the partial pressure of that CO2 is through the roof. It's higher than atmospheric pressure. So you're going to get lots of CO2 dissolved in that soda. You put it in the fridge, it's going to cool it down, you're going to get even more CO2 dissolved in the soda. And it's going to be nice and cold. Now you crack that open, enjoy your nice soda, you shut the bottle. But air has gotten in. A lot of that CO2 has escaped, and now the partial pressure of CO2 is much lower. The total pressure may very well be the same as it was originally, but there's a lot of air in that headspace. Not to mention the headspace is now bigger. That goes in the fridge, CO2 will leave the soda. It comes to what we call an equilibrium, where the amount coming in and going out balance out. And then you take it out and you pour yourself a new one. So in this case, you're best off, one, trying to drink that soda as quickly as possible so that it doesn't have time to escape and leak out of the bottle, and you keep as much of that CO2 in there. And also you start out with a much better start if you put the bottle in the fridge and let it get nice and cold before you open it. That way you get as much CO2 in your soda right off the bat. Okay, so with that said, enjoy your sodas in moderation, of course, and have a wonderful day.